Each year, the shattered remains of thousands of wrecked cars end up in junkyards just like this. These rusting hulks are grim testimony to increasing injuries and fatalities that plague our highways. This year alone, roughly 45,000 Americans will die on our roadways. Some of these deaths are preventable. Hi, I'm Mike Lech, and welcome to Adventures in Scale Modeling. Since 1939, Mercedes Benz has been a leader in the cause of automotive safety engineering. They developed a number of passive safety systems, those that protect passengers in the event of a collision. Mercedes Benz and other forward-looking companies have pioneered such important features as seat belts, crumple zones, telescoping steering columns, and even airbags. Today, a variety of manufacturers and research organizations are working feverishly to institute new safety standards towards their ultimate goal to produce safer cars and to save lives. On today's Adventures in Scale Modeling, we'll visit a Mercedes-Benz research facility and learn about some of the first passive safety systems developed for the automobile. But first, let's start building our model of a Mercedes-Benz crash test car. Safety engineers use automobiles in a very unusual manner. Well, today in the workshop, our master model builder, Mike Fleckenstein, is here to show us how we can use models in an unusual way. Mike, we're going to be building a crash test car today. And as many stores as I've been in, I've never seen a model of a crashed car. How do we begin?
Well, Mike, like any modeling project, we need to have our reference photos in line. And I brought one along that shows an impact test.
Okay, what did this show you?
Well, one of the features we can see in this top photo is a crunched up front fender. And on the one directly below it, a shattered windshield and a bent suspension component.
Well, this looks like it's going to present a challenge to us. Where do we start?
Well, we start by preparing our parts to look like this photo, but first we have to wash our hands.
Okay, let's go back to the sink and wash our hands. It's a step we cannot do often enough.
Oh, here you are.
Oh, thanks. Okay, now that the hands are clean, I would think, Mike, that the most difficult challenge would be bending the fenders and the hood, crunching that metal. How do we do that?
Well, let me bring over an undamaged component. What we're going to be doing is using our normal household nippers, covering up the leading edges and masking tape.
Why is that?
We do this because in their uncovered form, they would have serrations in it, and that might damage the plastic.
Oh, that's right. It would just put those little indentations on our car.
Right.
What do you do with them now?
Well, taking the component, very gradually we would bend up the point that we wanted to show the impact. We'd use our reference photos to determine that that was the end that had gotten damaged.
I was going to say, how did you know that? Just randomly, or you actually looked at the photos there?
Photos are very important. We'll just bend it very slowly, watching for a crack to form at the bend point.
Why is that?
Well, that would mean that the plastic is a little bit too brittle, and we'd have to take other steps to avoid damaging the part further.
Let's see that hood, how it's bent. Oh, it's a good bend. Now, what would you do? Would you continue down the hood until it was all bent?
Exactly. And if we did see it start to crack, we'd have to use a normal household hairdryer to heat the part a little bit, soften it, and then we can continue with the technique.
Well, let's see that step. This is something that we have around the house, basically. Oh, very simple
Regular
hairdryer.
hairdryer, again, on low heat setting, because high heat setting might melt this plastic.
Oh, so if it's a thin piece, be very careful.
And just for a few moments.
So you can heat this and go back and bend, heat it, go back and bend, couldn't you?
Exactly. It's really a trial and error process until we get it right. Looks like about right now. We'll give it a try. Bend this other end up. And you can see how much.
Oh, much easier to see there.
Just a few minutes will do it.
What would happen if we would break off a piece before heating it?
Well, I'm afraid we'll have to buy another kit.
Okay, well, we want to use that hairdryer, make sure that it's nice and soft. And there we are. Our hood is now bent. And you do some more work to that, but you really have a good start here. Okay, now one of the other things in a crash test car would be the windshield. It usually gets shattered. How do we simulate that?
Well, again, we'll bring over our undamaged part. When the windshield is manufactured at the factory, they have a plastic film that goes between two layers of glass. That's to prevent the windshield from shattering into a million pieces on impact. More or less, it just forms like the branches of a tree.
Yeah, rarely do we ever see a hole in the windshield. It's usually shattered out and then it's joined together by, like you said, like a spider web effect.
Right.
How do we simulate that?
Use a hobby knife, very sharp, preferably new blade. And again, working from the point of impact, our reference photos, basically carve tree branches, or the shape of tree branches, into the windshield, very lightly.
Well, so you just draw your knife blade across the windshield.
Right. Let's give that a try.
Yeah, let me see how much pressure that I have to put on this to make a tree branch. So I can, you've made some branches. Could I go back and do little ones?
That's exactly right, Mike. And matter of fact, the more little ones you have, the more realistic it looks. You're doing fine. Looks great.
You know, Mike, what's important is I'm not really putting much pressure. The actual tip of this blade is doing all the work.
Exactly.
Very simple step.
I think you've got it.
Okay, now that the windshield is scribed like this, how do we affix it to the body?
Well, clear parts represent a special challenge. We can't use either super glue or plastic cement because they would both fog the clear plastic. What we need to use is a regular contact type adhesive, and I have some over there in that orange tube.
Okay.
You just bring it
the
over.
product that you use here.
Right.
What's so special about this stuff?
Well, it won't fog the plastic, and it'll tack up really quickly, and we can just fasten the windshield into the body.
Okay, well, let's see how you're going to do this.
Remove a cap, and just apply a very narrow bead along both attachment points.
Oh, just right on the windshield.
Exactly. Now, we'll let this tack up for a few seconds, and while it's doing that, I'll get our car body, bring it over. We'll be affixing this from the inside because we've applied the cement on the outside surface of the windshield.
Okay, can I give you a hand and hold it for you?
I'm just going to blow on this so I can make it tack up a little quicker. And we'll just take our windshield,
Pop it right in there.
lay it in place.
Oh, yeah, well, this is a regular model kit, so we have locating holes as well.
And hold it in place until it sets up. And it shouldn't take too long. Matter of fact, it looks like it's pretty good right now.
That's because it's such a tacky glue.
Exactly.
You ready for me to spin it over?
Give it a try.
Okay, well, you're right, there it is. But I do see one minor flaw here, or what I would consider a major flaw, Mike, and that is the glue is all on the exterior parts of the windshield, and it really does look damaged and not realistic. What happens now?
Well, one of the advantages of using this type glue is that you can get it off while it's still in a semi-soft state. And what you can do is take your toothpick, lay it on the glue that you want to remove, and start twirling it. You do that, notice how the glue is attaching itself to the toothpick and coming away from the window?
Oh, yeah, I can see. So what's happening is that the glue is still tacky enough to come right off.
Right, and you just keep on working on it until it's all off and gone.
That was a great technique, Mike. Now, one of the other dramatic things that you see on a car that has been in a crash or an accident is that the wheels are usually bowed in, the frame is bent. How do we simulate that?
Okay, again, I will bring over my parts that I prepared.
All right, we have a suspension here.
We have a tire hubcap combination, a brake shoe, and inside wheel surface.
Mike, now that we have all of our parts, how do we proceed?
Well, we'll take the prepared chassis combination and attach the wheel and brake unit on at an angle to represent the crash damage. Now, normally, the wheel would go on perpendicular to this spindle. That's the way they call it because it wasn't damaged. We have to put it on an angle.
Yeah, we want to point out that the model maker built this car to be built correctly, and we're purposely putting angles and bends in it.
Right. So we'll start by taking the brake disc, putting it over the spindle at the angle we want, and holding it in place.
Okay.
Now we'll be trying a new type of glue, liquid glue, to fasten that brake disc onto the chassis. We'll be using this while it's not as quick as super glue. It does provide a much stronger joint.
All right, let's go ahead and put some glue on our angled brake disc.
Put it on there. We'll hold it in place while it sets for a couple minutes.
Of course, we want to have some patience here. We don't want to rush the glue. Even though it is semi-fast drying, we want to take the time to make sure it's set up correctly. And while that's doing that, let me ask you about that spindle. We have an angle on the brake disc yet the spindle is still straight. Now, if we went to put our wheel and our tire on, wouldn't it be put on straight, Mike?
Well, we can't have it there and put our wheel and tire on at an angle, so we have to get rid of it.
How do we do that?
We use a pair of wire cutters and put it over the spindle, hold our brake disc in place, and at the same time, try to keep your thumb over the spindle so when it snaps off, it won't hit you on the hand.
I want to practice some safety here.
Okay.
Okay, now by removing the spindle, you have a nice flush joint, and it is angled. Where do we go from here?
Well, normally we'd attach the tire and wheel combination, but we got to remember we still have to paint this. If we had the tire on it, we'd ruin it. So we'll just take the tire and hubcap, set it aside, and work with the back side of the wheel combination and fasten that onto the brake disc, thereby giving us our angled wheel.
Okay, we don't want to go too many steps ahead. We want to make sure that tire is left off and only the wheel goes on.
Right.
Okay, well, go ahead and fasten it on there so we can get a good look at the angle that we're trying to.
Again, we'll use our liquid glue. Put a little drop on there, some on there, and just fasten it on. Again, holding it in place until it sets.
And that's the angled effect that we want. Well, Mike, these were some really nice techniques. You showed us how to make a crash car out of a model, which is very unusual for model builders. And that was the first technique, which was to crumple up the metal with the hair dryer and the pliers, and of course moved into the damaging of the windshield with just light pressure on that hobby knife, which is really great. And of course our final technique, the bending of the suspension. Well, while these were great tips, why don't you work on a few more as we head off to Sindelfingen, Germany, and the Mercedes Benz Safety Development Facility. We're here now with Professor Hoover. The professor is the director in charge of passenger car body development here at Mercedes Benz. Professor, welcome to Adventures in Scale Modeling.
Nice to meet you.
Professor, tell us, what is passive safety?
Passive safety is a very important thing on safe cars like a Mercedes. Passive safety helps to reduce and to avoid injuries in an accident and to save lives.
Now tell us, you have a car here that's been pretty well smashed up. You test cars like this here. How do you do this?
Yes, we throw cars like this into a fixed barrier. As you see it in the rear, there's a 1,000 tons heavy barrier where we smash cars into. And we measure a lot. We have dummies inside the car, and we measure the accelerations in the head and the chest to learn how the people inside the car would survive that accident.
Professor, can you give us a little bit of background history on where Mercedes started with its passive safety development at first?
It's as far ago as more than 50 years when we started investigation on safe cars. This, for instance, is a very stiff floor panel of a passenger car reinforced by this bars to get a very, very stiff passenger compartment.
So that was one of the very first things that Mercedes did, is make a rigid frame.
Yeah, that's true. Not only a rigid frame, but also a whole passenger car compartment which is very rigid in an accident.
Okay, and what was the next step for you?
One important step was to improve the steering wheel. We very early learned that energy absorption by a collapsible steering wheel is very important. And this was a very early patent from 56 with a collapsible element behind the steering wheel.
So this was one of your very first patents on the steering wheel.
Yes, that's true. But another very important safety feature inside the steering wheel is the airbag. And I can show you how it is installed in the steering wheel. An airbag functions by a gas generator that is inside here, and the airbag inflates very rapidly within 20 milliseconds and deflates again after an accident like this. And it works like concussion.
So it's like a big gigantic pillow coming out into your face.
That's true.
Now, Professor, can you show us some of the examples of how this passive safety has worked in the car that you've crashed?
Yes. You see that the front end has been deformed a great deal and has absorbed energy, let's say. But the passenger compartment is still intact. So you can open the door, for instance, to rescue the driver, and nothing has intruded inside the passenger compartment.
Yeah, the airbag is coming out
The
there.
airbag here Has come out, yes.
So the passengers in this car will be pretty safe.
Pretty safe and stays very fine.
Well, Professor, thank you for sharing with us some of Mercedes' commitment to safety. And thank you very much for coming on to Adventures in Scale Modeling.
Welcome. Thank you.
At Mercedes Benz, research, development, and testing has led to many advances in automotive safety. That same innovative spirit is important to us as model builders, since we want to attain the same detail in our models. Now, Mike, when we want to add details to our crash test model, where do we go?
Go back to our reference photos, Mike. In this one, we'll show several additional details. You'll be able to see the registration number that they use on keeping records of tests, the calibration marks they use to measure displacement between two opposing body panels, and also the test dummy used to transmit data on the stresses that are on the occupants during impact.
Okay, now I may have some questions about the registration marks, but I would just imagine using details for the number.
Well, it's not quite that simple, Mike. If you allow me to go back here, I'll bring back a pre-painted body that we can work on. You'll notice that this body is painted in a flat finish paint. And the reason for that is in the factory, when they use a car for a test subject, they wouldn't bother to put a final finish on it because it just get ruined anyway. So they leave it in their primer coat.
So as model builders, we could save some time as well by not finishing out to be perfect even.
Right, so you leave it in a flat finish primer, but because of that, we can't use decals. Because the decals would just silver up as soon as we put them on the flat finish.
So where do we go?
You go to Dry Transfer Letters, Mike. And you can find this in any art supply store.
Oh yeah, I'm familiar with these, and they're in art supply as well, and they're very inexpensive.
Right. And the way we apply them is by using a burnishing tool.
Oh, this is a new tool for us to be looking at. What is this? Where do you pick it up?
Actually, it's from a drugstore. It's meant to be used on your cuticles to straighten and clean them.
Oh, another very inexpensive tool, but it has a blunt end. That's what we want.
You have to have it one thing to apply the dry transfer, Mike.
Okay, Mike, how do we work with them?
Well, first off, could you get me the easel? It might make this a little bit easier to
It's
see.
right here. Anything to make your job easier.
Thanks.
Okay, there you go.
All right. Well, we'll set the subject down like that. And what we're going to be doing is applying the dry transfer letters to the trunk area.
Okay.
You just hold that in place, Mike. On the side.
Yeah, no problem.
Thank you. We apply the dry transfers with the flat side down. That's because the sticky side of the letter or number, whatever we're going to use, is on the flat side. So what we do is position the dry transfer letter where we want it on the trunk and use our burnishing tool to rub it in place.
Oh, so we're rubbing it off the sheet onto the car.
Right, not much pressure is needed either. Just enough to make it lay down. Now when it's on, in the place we want it, we just very slowly peel it away.
And you have a very beautifully placed S. Now, how do we keep a straight line?
Well, the manufacturer of the dry transfer sheet is provided for that by keeping the letters in line after line.
So he's giving us a straight line.
Exactly. What we can do is use the previous letter to calibrate the next one.
All right, show us how you do it.
Okay, then we put shiny side up, flat side face down. And let's say we wanted to put the second letter being an S. We would line this letter up here and use it as a guide to lay down the next one.
Yeah, you just use one letter over the other one.
And we can, again, peel it away, and there it is.
It's very straight. Well, why don't you add a number so we can get a real feel for how this works?
Okay, would you like to try this one?
Yeah, well, you hold the model.
I'll hold the
and
model.
do the dry
I'll
transfer.
overlay the sheet down. We'll overlay the R over the S.
Give me a number. Give me a
Another
number.
number. Okay.
You want me to do number one?
Yeah.
All right, now let me see how you got that straight there. Put your finger there so I can see it. I just want to get it nice and straight. Okay. Well, I'm overlapping. Move it this way. Okay, I'm ready to do it.
Okay.
And what would happen if I don't rub the entire number down, if I leave something?
If you're not satisfied with it, Mike, you just peel it off with a piece of masking tape. They come right off.
Oh, it's very easy to correct our mistakes here. All right, let me see what I did. Well, not as straight as you, but boy, it certainly was easy. And if I had to, I could lift that right off of there.
Exactly.
Okay, now, Mike, what about those calibration marks? You taught us a great lesson in the letters, but what about those little dots?
Well, Mike, can you take this and put it down, please? What we can do, I'll go back here and get what we need to do the next technique. It's a line pen, which you can buy again at the art supply store, and some white water-based paint.
So this is the fine tip pen.
That's all.
Okay, how do we apply our dots?
Okay, we'll shake up the paint a little bit. Take the cover off. What we'll be using is just a normal toothpick, Mike.
So we want to use a round toothpick here?
Round toothpick. Basically what we're going to be doing here is turning this toothpick into a rubber stamp.
Okay.
Same idea.
How do we do that?
Imagine the diameter of the white calibration mark that you want, and cut that toothpick off right at that diameter. For instance, there.
Okay.
We created that rubber stamp now, and we can use that as a template to put the white dot in the model.
Well, let's see you work with it. You'll go right into the paint directly.
Right. Now, because they use these dots to measure the displacement of the body panels, we want to put them on opposing spots. In other words, right there for the first one,
Go back into your paint.
and there for the second one.
Oh, this is really good.
Also, imagine that one of these panels was being showed after impact. You would want to have the opposing dots also offset, as they would have been after the impact rather than directly across from each other.
Yeah, that would make sense as well. And of course, we know that by our research photos. Okay, now once the dots are painted on there, where do we go from here with this paint?
Well, now we use this line pen to put the center black dot on top of the white one. And I prepared some dots on the other side of the car. I'll turn it around, that are dry already.
Okay, I see them there.
And all we'll be doing is, I can test this on top of that, make sure it's coming out okay. Just coloring a dot. The same
That is
thing
really clever.
here.
That's a perfect job. Those calibrated dots look just like the one on the test car in the photo. Mike, what else can we add to our crash test car model to add more realism?
What we can add to test on, Mike, it's used to measure the senses on human occupants when the impact occurs.
Where do we get those from?
Well, unfortunately, we have to start with some commercially prepared racing car figures, or as we have here, pit crew figures. The problem with them, as you can notice, is they have a lot of molded on detail, and we have to get rid of that because the dummy, as you saw in the reference photos, was virtually plain, nondescript.
Well, how do we do that?
We have to use a moto tool to get away all the molded on detail.
Okay, well, bring it in and let's get it off of there. Now, what else do you want me to do with this? Do you need this anymore?
No, we don't need that right now because we can grind down the detail on the head.
Okay, now as you plug that in, I want to bring out a question here. What happens if a molder does not have a moto tool?
Well, you could substitute the use of the motor tool by using a file and some sandpaper to get the detail off. It would take longer, but same result.
But we're not lost without a moto tool.
Absolutely not.
Okay.
We want to set the motor tool in the lowest setting and start to grind away all the molded on detail.
Okay.
We want to get rid of the cheekbones, the lips, the grain of the hair, anything that would give it too much detail.
I almost want to look like an early mannequin that we've seen in the
That's right.
department stores.
Now, after we do this, we want to continue the same level of removing the detail from all the other body parts. And we want to use the body parts that we need to position the figure in the car when we finally put it in place.
Well, what does this piece look like when it's finished?
We painted a flesh tone, as you can see, and it's virtually plain, nondescript.
Okay, but there's some holes in his head. What are those for?
Well, you remember the reference photo? They had the sensors mounted on the side of the figure's head, and also the wires leading back to the computer equipment in the trunk of the vehicle. That's what we want to mount there. The way we do it, we take the line pen and color in some spots over those holes and attach some wax thread to represent the wires. And that's it.
Just buried behind the back of the crash car.
That's right.
Okay, what does the finished model look like?
I believe it's over on the shelf, Mike. Could you bring it over, please?
Okay, I'll bring it in. Now we can see the dummy inside there with those wires coming out of its head. As I place it in here, we can just quickly review some of the things that you've taught us today, and that is how to bend the metal, how to shatter that windshield, put the calibration dots in with the white paint and the pen. Of course, our crash dummy looks great inside there. And of course, wouldn't be complete without a bent frame. You did a great job for us, Mike. I'm going to be proud to display this upstairs in the museum.
Thanks for asking, Mike.
Modeling a wrecked car is more complicated than it sounds. Remember to use a hairdryer to heat the car's body so its parts can be bent and shaped, and a common hobby knife can be used to etch a shattered glass pattern into the plastic windshield. In an age when high-speed transportation has become almost commonplace, the application of science to automotive safety has become increasingly imperative. Each year, auto industry leaders like Mercedes